Before we start, I'm letting you know this is going to be a controversial video for some, as I'm going to be covering animal welfare of fish in aquaculture fish farming. Awareness around the issue of fish welfare in aquaculture continues to increase as the general public becomes more concerned about our food systems and perceived factory farming practices. The topic of animal welfare are causing food markets to take notice, even going so far as establishing specific animal welfare requirements for how fish are slaughtered. So while there may be disagreements in science around the issue of whether fish feel pain, how aquaculture producers take care of their fish have become more important to the consumer and retailer, and how our fish are treated from cradle to grave. Fish welfare is now having economic ramifications. So what are the animal welfare implications of various aquaculture practices? In this video, I'm going to focus on critical animal welfare processes and address the concerns of the public on animal cruelty and factory farming on fish farms. If you've ever had the opportunity to visit fish farms, you will quickly realize that fish farming varies, and it is a multifaceted operation which involves animal biology, engineering, a variety of specialized technology, logistics, and people management. I think it's almost impossible to separate the working procedures in fish farming from fish welfare. While there is no way I'm going to cover all components of animal welfare in aquaculture, we are going to discuss some of the critical animal welfare processes during general fish farm management, while handling fish, and lastly, fish welfare at slaughter. But before we get to these before, during, and after harvest fish welfare issues, there are additional factors that need to be covered first. The biggest of these factors to understand are those that confound animal welfare of farmed fishes. One of the biggest factors are that there are over 350 fishes farmed in aquaculture fish farming. These fish come from almost every possible habitat and have adapted to an even greater diversity of environmental conditions. As one can imagine that each fish species has a preferred environmental condition such as light, water, temperature, depth, flow rates, and water chemistry. This can become even more complicated when we consider the varying needs of different life stages, such as in developing fish eggs, larvae, juveniles, and adults. For the majority of species, only basic requirements are known. For some fish, like tilapia, different strains vary in their desired environmental conditions. Rainbow trout or Atlantic salmon, for example, through domestication and intensive genetic selection have different environmental tolerances and have behaviors compared to undomesticated farm fish. The next critical factor I'd like to address is staffing. I don't like to compare the animal welfare of capture fisheries to farmed fish, as the fish reared in aquaculture usually require 100% of their existence on the farmers that farm them. Good fish welfare then requires that the staff of these farms are well trained, as they are the ones that usually work directly with the animals. So what does trained in animal welfare mean for these employees? Trained means that whomever is responsible for the daily care of fish have a basic understanding of welfare issues, which include most of what we will discuss over the next few minutes. These welfare issues include environmental and biological requirements of the fish, such as water quality and feed, and they should know what is good handling from poor fish handling. Can these staff members detect altered fish behavior, which could signal something is wrong, such as disease or poor water quality? And will they be able to take immediate action or know the chain of command if there was a challenge to life support systems? I have never met a fish farmer that didn't take pride in the quality of their fish. So poorly trained staff in fish welfare not only jeopardizes the quality of those fish, but also the sustainability of the business. Let's start with critical pre-harvest fish welfare processes. I think one of the biggest disconnects between animal welfare advocates and fish farmers is the lack of understanding that for fish farmers, good welfare starts, and in many cases, ends with water quality. Life support systems for aquatic organisms are critical because these animals are surrounded by this fluid medium for which their existence is coupled. So water quality without hesitation is the most critical factor for fish welfare, as poor long-term water quality or rapid fluctuations in water quality can have negative consequences such as physiological stress that prevents the fish from eating, or even worse, death. My California fish farmer knows that poor water quality impacts the sustainability of their farm. That is, directly impacts their business. When I'm talking water quality, I'm referring to temperature, pH, the oxygen concentration, ammonia, nitrate concentrations, and other saturated gases like carbon dioxide and nitrogen. For saltwater fish, you could add conductivity and salinity. So when someone, such as myself, tells a fish farmer they aren't practicing good animal welfare, they look at me like I'm crazy because they take water quality seriously and are practicing good fish welfare. Unfortunately, in my experience, this is where the perception of animal welfare and fish farms begin to diverge. Another big disconnect between fish farmers and animal welfare advocates is fish stocking density. I can't tell you how many times people will look at a fish tank and immediately come to the conclusion that the fish tank is overstocked. What people don't realize is that there are a number of factors that influence stocking density. Let's start with animal behavior and biology. For most fish, there's safety in numbers, and most fish prefer to exist in schools. Now this is where it starts to get tricky, as some fish prefer to be packed together, while other fish require more space to stretch out. Fish such as Arctic char and tilapia do great in high densities, while fish like white sturgeon, who utilize the entire water column, and when they get large, really need to stretch out. But we can't ignore other factors of fish behavior, because if you don't have enough fish in the tank, you will see fish aggression and bullying, such as being territorial around the fish feeder. This is true for a number of common species in fish farming, such as rainbow trout, tilapia, catfish. In this instance, successful husbandry only occurs at densities in which all fish in the tank form a community. So having too little fish and a low stocking density isn't necessarily a good thing, as you'll end up with one really big fish and a good number of small fish, or even fish mortality as the bigger fish beat up on the smaller ones, or even eat them. I don't even want to start discussing differences in male and female behaviors. I guess what I'm saying is there are a number of factors that can be overlooked by a person who is not as attuned to the species farmed. This definitely leads to differences in perception between the public and the fish farmer. Now, there are a couple of other hidden factors someone could easily overlook when addressing stocking densities. So my California fish farmers have learned long ago that when you push your system by overstocking, requiring more feed and more oxygen, that at some point your luck will run out and you'll get a disease issue or a change in the environment, such as a heat wave, which really stresses your farm. When this does happen, worst case scenario is you have a large fish kill. This regularly happens in systems that do not utilize water flow, such as those in earthen ponds. For many systems, the flow rate is important as it provides fresh oxygenated water while diverting and diluting wastes. Now, I don't want you to think that this doesn't happen in fancy recirculating aquaculture systems either. But as you would expect, with higher flow rate or higher water turnovers and greater system water volumes, many culture systems can handle much higher fish stocking densities, as the increased flow or volumes prevents dead zones, or in raceways or tank systems that dilute the waste products, or directs the unwanted food or food wastes out of the culture systems. Speaking on disease management on the fish farm, monitoring and treating fish is an important process during this pre-harvest period to increase animal welfare. Disease management starts with properly trained staff and having a monitoring program. Maybe having access to a veterinarian or other animal health expertise is also beneficial. Probably the best preventative method is a good biosecurity program. Biosecurity would include strategies to prevent cross-contamination between different populations on the farm. Increased fish welfare would include separate nets for each tank, cleaning and disinfecting equipment between fish and when spawning, and even preventing staff from wearing the same boots or waders without cleaning and disinfecting before moving between ponds or even in buildings. Other measures could include isolation tanks or a quarantine system for sick fish, or when bringing fish from other locations. The gold standard would be to keep replicate-independent systems and equipment, even going to the extreme that staff don't move between farms or buildings. Fish health certifications, while not 100% preventative for disease, are also important for protecting the fish farm. Unfortunately, or fortunately, depending on where you sit on the spectrum, there are limited options for prophylaxis in aquaculture. There are few vaccines available for fish, and of those, they are primarily focused on salmonids, which includes trout and salmon, but also catfish and tilapia. Other prophylaxis measures include salt, iodine, formalin, and peroxides. I want to mention that I'm not covering all pre-harvest processes and factors that influence fish welfare in an aquaculture fish farm. We still have fish handling and slaughter to get to. But I don't want to move on before mentioning some environmental factors that affect water quality and subsequent fish welfare. These environmental factors can include exposure to excessive sunlight, which increases water temperature and can lead to toxic algal blooms. Increased temperature stress from rising ocean temperatures and ocean acidification from dissolved carbon dioxide impact many marine fish. Mammalian, bird, and fish pests are other stressors that need to be controlled, as many are predators of our fish, and even some carry disease from the wild to our farms. Other disease of pest stressors that need to be considered include bacteria and viruses, as well as lice and flukes that parasitize fish. There are environmental factors in closed hatchery systems, as with pumps and blowers, you could end up with underwater noise and even unwanted vibrations that could stress some fish. Even the tank infrastructure can negatively influence fish welfare, such as when they have sharp edges or are rough surfaces, leading to belly or fin sores. Perhaps the tanks are too small or restrictive for healthy fish growth. I hope you are beginning to see the depth of consideration needed for good animal welfare in aquaculture. We have only covered some of the most critical processes of pre-harvest issues. What then are the critical processes of fish welfare during harvest and fish farming? During fish harvest, many fish welfare issues occur around handling and transportation. I want to clarify that handling during harvest occurs at various times during fish production. Handling includes netting, screening, and crowding fish for a variety of activities, which can include weighing and grading, health assessments, vaccinations, labeling, sexing and breeding, reducing stocking densities, pumping to move fish, and for our caviar sturgeon, regular monitoring of fish eggs for caviar quality. Handling can also occur for transportation, which usually is accomplished when using specialized trucks between farms, or for stocking lakes, rivers, ponds, or to send live fish for slaughter, which is regularly called fish processing. Some fish are more sensitive to handling than others, but the length of handling and physical restraint should be at a minimum. Handling can occur in water, but regularly fish handling is done out of water. Handling stress regularly contributes to mortality in fish. To clarify, some fish are able to be handled more than others, meaning that they likely won't die from handling, but that doesn't mean the fish do not stress from the activity. Stress response in fish can contribute to bruising, lesions, increased susceptibility to diseases, especially those that impact the fish mucus coating, which can manifest later as fungal infections. Some fish may not eat for months after handling. To further complicate the situation, different fish are more or less tolerant of handling at different ages. I found that handling younger fish leads to increased mortality, while older fish may exhibit altered feeding or swimming behaviors over a prolonged period of time. It should be noted that the sensitivity of the fish to handling is also dependent on the temperature, and that stress is increased with elevated temperatures. So moving fish early in the day or choosing a cloudy day, being out of the direct sun would be an example of improved animal welfare during handling. I think it should go without saying that fish prefer to be in water. That is where the majority of fish extract oxygen from water. Basically, when fish are out of water, they are slowly suffocating. There are times that fish will be out of water, but any modifications to handling that keep fish in water with improved access to oxygen are other good examples of improved fish welfare. A good example of this activity is catfish pond harvesting. Catfish are regularly seined into an area where they can be sorted and collected by a braille net. Since fish are crowded and fish respiration increases because of stress, oxygen levels can become dangerously low. Catfish farmers, to mitigate this welfare issue, station paddle wheels in areas just adjacent to the area the farmers are working to increase the dissolved oxygen levels in the immediate area where the fish are concentrated. To the untrained person or the animal welfare advocate that is unaware of farm practices, this seining activity and fish crowding could appear very dangerous to fish health. Some of the more common animal welfare issues I see in aquaculture is when moving fish. I regularly see fish loaded or moved in buckets, nets, or totes, and sometimes over surprisingly long distances out of water. This, of course, is a consequence due to the weight of water. It's heavy, more than 8 pounds per gallon. One of the easiest methods to increase animal welfare is moving fish in a pipe, a sluice system, or a fish transport truck with water. I know that this isn't always possible and that each location and situation needs to be evaluated, as isn't it better to handle fish once than perhaps twice? Another critical issue that occurs on farms is that in order to save time, either for the fish or the farmers, not to mention our backs, is that way too many fish are piled upon each other, which ends up crushing the fish at the bottom. Again, not all fish farms are equal, and that each fish handling situation needs to be evaluated separately, as a 250-pound net with 5 adult sturgeon is not the same as 250-pound net with 251-pound one-year-old rainbow trout. One animal welfare change I personally really would like to see my industry stop is throwing fish. It is just not appropriate to throw animals. This regularly occurs when sorting and harvesting fish. I usually see this when people are sorting fish, loading fish into nets, or when people are moving fish from tank to tank. While throwing fish, the fish will regularly hit metal, such as the chain or the ring the net is suspended from. Perhaps the fish will hit the side of the tank or even land on the ground. I know that this can sometimes be subjective, as what some people consider placing fish into nets, others would consider this as throwing. It is, of course, a difference in perspective, but ending the practice of throwing fish is a simple change that improves fish welfare on fish farms. I haven't forgotten about transportation. It's just that there's so much to talk about animal welfare during handling. So let's take a minute to talk about transportation stress. I've heard animal welfare advocates rail about dark, scary transport trucks. This is usually an inaccurate characterization. In fact, dark tanks reduce fish stress. I'm not going to suggest that fish aren't stressed during transportation. They have been netted from their ponds or tanks, sorted, harvested, and loaded into a small, constrained new environment, sometimes at high density. That and more is going to be stressful for our fish. There are a number of other issues around transporting fish, such as maintaining water quality, especially reducing carbon dioxide, and managing water temperatures. Modern trucks and trailers are better at maintaining life support systems, especially for those long distance trips. One of the biggest ways to improve fish welfare and reduce fish transport stress is to stop feeding a number of days before transport to maintain good water quality. Keep water cooler, displace dissolved carbon dioxide, and prevent overcrowding. And keep the trip as short as possible. Again, some fish will handle crowding better than others. There are times that crowding is actually preferred, as it reduces the likelihood of startle injuries during transportation. There is a good number of issues to address that go into achieving good fish welfare in aquaculture around fish handling. While it can seem overwhelming, there are so many small, simple changes that can be made without an overhaul of an entire fish farm. Mostly, it just comes down to stepping back, changing old practices, and just being willing to make small tweaks to the operation. Sometimes there are real costs associated with that change, while other times those are only perceived costs, with many other benefits, not just for the fish, but also for the staff and the business. In our next critical process of animal welfare on fish farms, I feel post-harvest handling is going to require the greatest change in the aquaculture industry to achieve good fish welfare. The good news is that most of the changes are actually simple and are so beneficial for the fish, the farm, the retailer, and ultimately the consumer. So let us have an open conversation about the controversial topic of fish welfare around slaughter. I'm going to state that I'm starting this conversation by default with the idea that fish feel pain, are sentient and aware. Critical processes around fish welfare at slaughter usually include many of the fish handling and transportation issues that precede slaughter discussed earlier. Fish are going to be stressed from those processes, and the degree at which fish are stressed prior to slaughter will only be accelerated with poor fish welfare. This stress is magnified negatively in seafood quality and shelf life. The best fish welfare at slaughter is when to the absolute minimum time and severity that fish experience stress. So I challenge my colleagues to ask themselves, what changes to current processes can be made to further reduce this stress? Whether you are a veterinarian, a farmer, processor, or natural resource fish biologist, an appropriate method for effective and immediate slaughter should be selected to improve fish welfare. To achieve proper slaughter for food fish, the American Veterinary Medical Association recommends a combination of first and/or second step methods when the first step does not achieve immediate mortality. These recommendations come with the caveat that slaughter is achieved using proper equipment, which are properly maintained by trained staff that are monitored regularly for effectiveness. I know this one's going to upset a number of people, but rapid chilling, also called hypothermic shock of fish, is not an approved first step method for temperate, cool, or cold water fish, as well as for medium to large bodied fish, as it takes a considerable amount of time for fish to succumb to the cold. When fish are placed in an ice slurry or worse, just on ice, fish will flail around for quite some time before slowly shutting down physiological processes or succumbing to suffocation. To increase fish welfare around slaughter, rapid chilling should be utilized as a two-step method. For increasing fish welfare and improving fish quality, I actually recommend using an ice slurry as a third or even a fourth step method. I just kind of made up that third or fourth step. But let me explain. According to the AVMA, humane slaughter methods are methods or agents designed to bring about rapid loss of consciousness and ultimately a complete loss of brain function in animals destined for use as food. In other words, they are recommending a first step method that first renders the fish brain dead and then followed by a termination second step method such as exsanguination that causes mortality. Exsanguination is a second step method whereby a fish is cut and blood loss leads to the final termination step. Furthermore, the AVMA recommends to minimize the stress in animals and to prevent human injury during slaughter, methods should maintain calm animals. For staff working with large fin fish such as salmon and sturgeon, human injury could mean directly from being hit by the animal, but also from repeated use injury or even being accidentally struck by a fellow staff member. So maintaining calm animals is a tough one for fish, as dewatering is going to increase fish distress. Here is one of those animal welfare issues where aquaculture is negatively targeted as factory farming and animal cruelty, and are challenged by animal welfare advocates. So to increase fish welfare during slaughter, a first step method should be considered that immediately stuns fish, creating unconscious or better yet brain death of these fish until a second killing step is applied. Having properly trained personnel is critical for maintaining good animal welfare during slaughter, as a number of fish may become conscious after improper stunning. A number of fish, if not experiencing an effective first stage stunning method, may remain conscious 15 to 40 minutes after blood loss or evisceration. The most common physical first stage slaughter method is percussion stunning. This is cranial concussion technique, also known as applied blunt force trauma, which is usually achieved with a weighted pipe, club, or hammer. This is usually manually applied, a rapid strike to the brain to cause immediate brain death, but this technique can also be automated. For large fin fish such as tuna, salmon, and sturgeon, a significant amount of force and energy is necessary to cause immediate unconsciousness. This is especially difficult when targeting a specific area of the head where the brain is located and when the fish is not calm and thrashing around out of the water. It is in this instance where fish experience poor animal welfare, as fish may receive off-target strikes or numerous strikes to the head in order to render them unconscious. This is also regularly conducted when the fish are out of water and sometimes long after they've been dewatered. I have seen percussion stunning done quickly and efficiently with excellent animal welfare. Unfortunately, this step can also be done poorly because of poorly trained staff, insufficient technology and procedures, and sometimes because of fish anatomy. I'm not going to go through all the approved slaughter methods now, but I will leave a link in the video description for the AVMA guidance document on humane slaughter for food fish. My laboratory is actively exploring the effectiveness of a number of methods for first and second stage slaughter to improve fish welfare, as well as fish quality. In fact, a number of studies have shown that increased animal welfare during slaughter significantly improves fillet quality and shelf life. I have considerable experience with a number of chemical and physical approaches, but we are focusing on increasing fish welfare using non-penetrating captive bolt for percussion stunning and electrocution as both the first and second step slaughter approach. I want to introduce the non-penetrating captive bolt as a first step slaughter method. These devices are usually a pneumatic tool that can achieve greater pressures by using compressed air than what can normally be achieved by manual percussion stunning. The challenge with using a captive bolt is that placement has to be exacting, otherwise fish will also experience numerous strikes, just like using any other percussion stunning tool. For large sturgeon, such as white sturgeon, that have a cartilaginous skeleton, the captive bolt stunner improves fish welfare over a weighted pipe for farm sturgeon fish that we feed and grow for caviar and meat products in the western United States. The cartilaginous skull of these fish can almost be 2 inches thick, which pose considerable welfare challenges. After the application of the captive bolt stunner, I recommend exsanguination in an ice slurry as the second termination step. In my opinion, this is the best practice for most large fish to achieve good fish welfare on fish farms and with fish processors during slaughter. I hope that you've watched this video up to this point and that you've come to realize the overall concept of animal welfare in aquaculture fish farming is very complex. A common misconception by many advocates against fish farming is that fish are treated inhumanely with overt animal cruelty in aquaculture. Farmed fish in most aquaculture operations are treated humanely as discussed, but that doesn't mean the industry can't improve animal welfare. Certainly, there are failures and aspects of fish welfare is lacking. Fish welfare is the extent to which fish are being treated in captivity in all life stages. As the demand for fish farming grows, so does the demand for aquaculture practices that result in a minimum of pain, stress, starvation, and other negative effects on fish. I read a report that said 900 to 2,700 billion fish are slaughtered annually across the globe. The global demand for fish has increased dramatically, and according to the Food and Agriculture Organization of the United Nations, the average consumer will see a 20% increase in the amount of fish consumed by 2027, and the number of fish that needs to be produced is expected to triple over the next 30 years. To learn more about sustainable aquaculture and animal welfare in California aquaculture fish farming, you should watch this video next. I'm Dr. Jackson Gross.